We will now continue talking about synthetic polymers in our macromolecule series. The polymers we're going to talk about today are made from addition polymerization reactions. And let's get down right to it. We talked about last time in our alkene series about ethene being the most prolific, could be arguably the most useful and yet possibly harmful byproduct of the oil and gas industry. And one of these byproducts is the ethene monomers, all right? Ethene, which is drawn here with a C, double bond C, and H just attached to it. Now, in the industry, ethene is also called ethylene. So if you hear this, don't get alarmed. It's just ethene with a different name. All right? All right. So when this C double bond C is bonded also with pi bonds, which are a bit strenuous. And so what will happen is that if a more electronegative element or radical or catalyst comes to it, it will break that double bond quite easily. And when it breaks, the free radical, when it breaks, chain reaction will happen in where all the ethenes will start forming forming long chains to form a polymer. And this ethene polymer is called polyethylene or polyethylene, which is noted in this condensed structural formula with C single bonded C with the parentheses with the H's now on the top and the bottom, and the long chain is noted by the subscript N, meaning however long that polymer chain may be. All right. Now, polyethylene is quite common in our plastic bottles that we use to drink Coke or mineral water or spring water. It's used in plastic bags, plastic bowls, and anything basically with recycle sign 1, which we'll talk about it in later. All right? It is by far the most popular type of polymer, the polyethylenes. Now, we can also now make substitutions to the hydrogen elements, and when you make substitutions to it, you can make a whole class of different types of polymers with different types of properties, or physical properties. And so the list is really, really long, but I'm just going to focus on a few of them. Another common polymer or monomer is called the propene. We talked about this. It's basically 3 carbon atoms with 2 of them double bonded together. And so you can write it as the methyl group here attached to the ethene. All right? When it forms a polymer, it will form polypropene, or by its industrial name, polypropylene, which you may have heard before. And so its condensed formula will simply be the same as the polyethylene formula, except that one of every other carbon will have a methyl group attached to the long hydrocarbon chain. And so polyethylene is quite popular to make robes, carpets, or other kind of packaging. Right. Now, another type of monomer is the chloroethene, where chlorine is now substituted on one of the positions of the ethene monomer. When these come together, it will form polychloroethene or polyvinyl chloride or PVC. Now we've heard of the word PVC in hardware stores because PVC is basically used to make the pipes, the drainage plumbing pipes that we have, and also artificial leather, and many other uses. It's quite sturdy. And another class of monomers is the phenolethene. Phenolethene has a benzene group attached to the ethene. So when it forms together, it will form polyphenolethene or polystyrene, as is known, or styrofoam. Now, we all know what styrofoams are, so its condensed structure will be the same as ethene, except with every other carbon will have a benzene group attached to it. And so we know what styrofoams are, so let's move on. And the last class of polymers I'm going to talk about is the tetrafluoroethene, or TFE. TFE is where all the hydrogens have been substituted by fluorines. And because fluorine is so electronegative, when it's attached to this long polymer chain, it will be totally unreactive to anything. And so when polyfluoroethene, TFE, comes together to form a polymer, it's called polytetrafluoroethene, or by its industrial name, Teflon, or brand name Teflon. Now, Teflon is basically the same as ethene, except all the hydrogens are now fluorines. And this polymer is used for all the non-stick cooking pots and pans that we have at home. All right. So now, how are these polymers made? These polymers are made from an ethene, which is attacked by a free radical. And this free radical will break the double bond chain to form a single bond from the radical to the carbon, plus carbon, and this first to second carbon, it's now a single bond with the second carbon having a free radical that will again attack another ethene, and this process will continue on and on and on until we have a long chain of polyethylene. So that is it for synthetic polymers. Next time we'll talk about condensation polymers.